The next topic we'll discuss here is our topic of constant pressure calorimetry. So this is when we're observing a reaction or some process utilizing, in this case, we have a simple calorimeter. So this coffee cup calorimeter is insulated. We have two cups kind of nestled inside of one another. And then we have our reaction mixture inside here. So when we carry out a reaction in aqueous solution, we're going to be measuring at constant pressure a change in temperature. So we have this thermometer in our setup here, and we can indirectly measure the heat change for our system by measuring the heat change for the water in the calorimeter. So what we're really looking for is the measurement, the reaction taking place in the water. But again, we're going to measure the water and then know that that's going to be equal to the opposite heat change for our reaction. So some numeric values that we should note here, we have the specific heat for water, 4.184 joules per gram Kelvin, also joules per gram Celsius. So when we measure delta H for the reaction, so the enthalpy change of the reaction, we can utilize this equality here because we're at constant pressure. If you remember, at constant pressure, we said that Q is equal to delta H. So some other terms that we might want to define here are that of heat of dissolution. So we have when something dissolves here. So this heat of dissolution is the amount of heat that is released when a solute dissolves in a solvent. So for example, if we dissolved sodium hydroxide, crystals or pellets rather, in water that could release heat, and then something like ammonium nitrate, when we dissolve that, that may absorb heat, so our beaker would feel cold. We can also look at what's called the heat of the reaction again here. So the amount of heat released or absorbed during a chemical reaction. We can indirectly measure that using this method of calorimetry. So in both of these processes, the heat of the reaction, heat of dissolution, we measure the heat of the solution and then we calculate the other value, the dissolution or that of the reaction. So